This Skywarn training course is presented by the National Weather Service offices of Gray, Caribou, Maine, and Burlington, Vermont. This is an advanced topic focusing on river ice spotting. My name is Sarah Jameson, and I am the Senior Service Hydrologist with the National Weather Service in Gray, Maine. Assisting with this training are Louise Faude, the Warning Coordination Meteorologist in Caribou, and John Goff, the Senior Service Hydrologist in Burlington. So let's get started. Tonight's focus will be on river ice and the dangers they pose to northern communities. We'll go through some background on some terminology and ice processes, a brief review of what the Weather Service will issue in response to various icing situations, and last, we will focus on how and what you as a spotter can report to us. I want to make clear that we will not be addressing mitigation techniques, as that is a role taken by other agencies. From our perspective, our focus is on providing the timely information to protect life and property. So what is an ice jam? This video, taken in Vermont on the Ausable River, clearly demonstrates the hazards posed by an ice jam. But by definition, an ice jam is a blockage in a river formed by chunks of ice and subsequently, and often very suddenly, altering the flow of the river. Ice jams can cost an estimated $125 million in damages annually across the nation. Now, when comparison with an event like a hurricane, these figures do not compare nearly as much. However, since the impacts tend to be fairly localized and in small rural communities, the financial loss can be very devastating. So why is the threat level with ice jams so high? Unlike a lot of other threats, they often flood with little or no warning. There's literally no computer model that's able to simulate the growth, breakup, and jamming of ice in a river, subsequently making them very difficult to predict. This means that decision makers are unable to proactively take preventative steps. And for us at the Weather Service, essentially we're unable to provide the timely warnings that are needed to alert communities of the danger. So this is where spotters come in. Spotters can help improve everybody's awareness on the growing threat. Real-time reports on river ice and river responses can help alert the communities up and downstream. You help fill in the holes in our situational awareness. Okay, so being in a northern climate, many of you, I'm sure, have spent a fair amount of time out on frozen lakes in the winter. You're probably somewhat familiar with the growth and breakup of ice, but I need to make this point very clear that river ice is different than lake ice. There are a lot of reasons why rivers are more problematic. River ice can come and go more rapidly and less predictably than lake ice. There are a number of ice formation processes that are common on rivers that are not seen on lakes, like frazzle ice and erosion from currents underneath. We're going to discuss these in more detail later, but I just want to make sure that people understand the distinction between lake ice and river ice moving forward. I want to give a shout out to the U.S. Army Corps of Engineers Cold Region Research and Engineering Laboratory, which is located locally in our region in Hanover, New Hampshire. They are the official federal experts on river ice and also maintain a database on past ice jam events. The table that we have here is what I screen captured from that database. And as you can see, the number of reported ice jam events in their database by state going past well over 100 years. As you would expect, we likely had more ice jam events than what is listed here. The reason for this is most ice jam events go unreported. This is where you all come in. You help us grow our historical records in addition to provide the timely information we need to provide warnings. If you've been in New England for long, you've probably heard of the record-breaking floods of 1936. The flooding was the result of an enormously deep snowpack and 3 back-to-back-to-back storm systems with lots of rain. The graphic here on the left shows the cumulative volume of water and runoff over the region. And yes, that is a 30 up in the White Mountains. So devastating flooding resulted from this particular event. But the first round of storms had a lot of contributing flooding resulting from ice jams. Very, very distinctive. The heavy ice cover had formed over the longer reaches of streams during the extended period of sub-freezing temperatures in January and February that year. So the ice was particularly thick and strong for March. Notable ice jams occurred on the Kennebec, Androscoggin, Connecticut, and other rivers. But ice jams, floods can occur even without the accompanying storm, and they can be just as impactful on a local level. We're going to start off by looking at ice processes and learning some terminology. We'll start with river ice growth. So ice growth is often estimated by accumulating freezing degree hours or days, but this method is better suited for stationary bodies like a lake. For a moving body of water, it becomes a bit more complicated. So we're not going to go into all the thermodynamic properties here today. We'll spare you that level of detail, but just be aware that things like the velocity of the water, the wind, humidity, cloud cover all contribute to the ice growth. So the best way to be prepared is to become familiar with your local history of when the first ice dates are, combined with an idea of how much warmer or colder this season has been, and give you an estimate on when you can expect the ice to develop. Okay, so once the temperatures fall below freezing, you begin to have super cold water. This will allow for the development of ice crystals. If it's a slow-moving or stationary body, you will get sheet ice, like a lake. If it is a turbulent flowing water, you often start with frazzle ice. The extent of mixing is going to greatly impact the type of the ice that's going to develop. Some terms that we use, we have ice disk, anchor ice, frazzle ice, slush, and then we have stable ice cover or sheet ice. So here are some images of frazzle ice. You've probably seen it before. Frazzle ice, similar to slush, forms is small ice crystals that form in turbulent, flowing, slightly supercooled waters, often in rivers, but it can actually happen on lakes if we get windy and turbulent enough conditions. Frazzle river grows as the ice pieces rub and bump into each other. Now, you don't often have an ice jam purely based on frazzle ice. However, the frazzle ice can help lock in larger ice blocks or rubble ice, kind of like glue making an ice jam stronger. So the presence of frazzle ice can be a contributing factor to ice jams. So if the water is turbulent or shallow enough, it can push the frazzle ice to the bottom of the river where it can actually attach. This is called anchor ice. The ice at the bottom of the river can subsequently reduce the channel flow capacity. So essentially what that means is it's going to take a lot less water to potentially reach those hazardous levels. Now, we're not going to ask you to go out and measure or assess the anchor ice. However, if you happen to spot it, you can report that. It's very difficult to assess, especially if it's a deep river. But like the example here, you can see some clear imagery showing that that ice is stuck to the bottom of this creek. When ice starts to develop on a river, it often starts off as frazzle ice or border ice. The images here clearly show some nicely defined border ice growth. The ice will tend to develop where the lower water velocities near the shore make it easier for it to expand. Ice can also pile up from upstream locations when it encounters the friction of the shoreline. So this again can help grow your border ice. Also of note, that long gap that's between the two ice sheets, that's often referred to as the lead, which is often separated because of the wind or the currents in the faster water. So in this image, you see kind of a combination of ice. You have rubble ice or ice chunks, probably mixed with some frazzle ice, broken up pieces of maybe some sheet ice or border ice. When it's flowing, we call these ice flows. Now, do you need to report that? Not all the time. It's not necessarily jamming. If it was a jam, you would call it as such. But if it's just flowing freely, it may be worth reporting, especially if we have coverage that is greater than 50% of the river flow. It might not be an ice jam concern where you're located, but further downstream, it's good to know. Pictured in this image is a nice solid example of sheet ice. So sheet ice or surface ice cover grows in place. It's thermally driven and dependent on the river and wind speed. So if we have a calm, frigid night, that's ideal for growing sheet ice. These can be actually the starting points or the toe of an ice jam from the rubble coming from upstream. And we're going to talk about that here shortly. So dams. So let's take a complicated process and make it even a little bit more tricky by adding some dams in the mix. Many of our rivers have dams. So how does that influence river ice? Well, unlike a lake where you can have stratiform layers of different temperatures, with a river, it's continually being mixed and you're getting water coming from upstream to downstream. So you're usually going to have kind of a more uniform temperature profile in a river. Now, if you have a dam, that can make it a little bit more complex because it's almost like a reservoir of water behind the dam that can have a little bit different temperature profiles. So essentially what it boils down to is it's pretty complex. It's best to look at past ice events to understand what's typical for that particular dam location. Fragile ice can damage the hydropower plant's intakes, and that can be more of an unseen hazard. Sheet ice can again cause problems by slamming into the gates. So essentially, what happens if we have ice jams at a dam? They need to be monitored closely. Thawing ice, very important part of the whole ice jam process. So thawing ice, often referred to as rotting ice, it's a lot weaker than your cold solid ice. One thing I have to point out is don't be fooled into thinking you can actually assess the ice thickness by the color. It's not a reliable way to assess the state of the thaw due to many processes that unfold over the winter. Essentially, there are three ways that you can rot the ice. You have the top surface melting, which is the most visible. You have the internal melting from solar radiation. So the presence of snow as an insulating factor can influence where and how much of that solar penetration there is. Then you have erosion or under ice melting, which is the result of the currents continually rotting away the bottom of your ice sheets. So surface color of the thawing ice sheets is not a reliable way to assess the state of the thaw. It can be either white, light gray, dark gray in the same thaw state. Melting on the ice surface, typically from warm wind, warm temperatures without wind, sun, or warm rain, relatively short warm spells can create a bunch of new hazards, some of which can last for several days or even weeks after the thaw ends. So knowing the temperature, wind, sunniness of say the past 7 to 10 days can give you a good idea of when we can expect ice weakened by thawing. Under ice melting from the moving water, well, that's a little bit harder to assess. In a river, the current mixes the entire water column enough to keep it approximately at one temperature. Warm conditions will melt the ice in the usual fashion, and warm rain might allow the water temperature of the river to rise. That is a whole nother problem that we'll address later. So now to turn our attention to the real hazard when it comes to river ice jams. The unpredictability of an ice jam makes them especially hazardous. We need to become more vigilant when the ice grows to at least 4 inches thick, as this can be strong enough to support a jam. Granted, this is going to really depend on the size of your watershed, how long is your river, how much water is going to be impacting it, building up behind it. But essentially, our rule of thumb is about 4 inches thick is strong enough to support a jam that could produce flooding. So as long as the flow arriving above the ice jam is increasing, the ice jam flood threat will increase. Obviously, colder temperatures will strengthen the ice jam and cause more upstream flooding. Now, if the weather turns warmer or there's more rotting of that ice, say from some warm wind, uh, it's going to weaken that ice jam. Now, if you weaken the jam and the pressure still building from upstream water, it may cause a sudden release of the impounded water. It's for this reason, it's important for communities up and downstream of the jam to be alert for any flooding. Okay, so here is a schematic of a typical ice jam from one bank to the other as it blocks the flow of the water in the channel. You have broken ice chunks glued together by often fragile ice or slush. So a midwinter jam may freeze in place. Now, it could freeze in place for several weeks or months at a time, especially up in places like northern Maine. So the problems could be ongoing, but one thing to keep in mind, if the flow underneath the ice is sufficiently low, you could have an ice jam with relatively little or no problems. But it's still important for us to be aware of the ice jam location so that should the weather change or the risk level be increased, we're aware of this mitigating factor. Okay, so we're going to take that same jam, but now we're going to look at it from a different angle. We're looking at it from upstream to the left, going downstream to the right. So if we start there on the left, upstream, you have the head of the jam. Okay, so that is the back end of the jam on the upstream side. You can see that we get increased water level because the amount of flow is not able to fully push underneath the ice jam, subsequently backwater effect. Then to the right, you have what is called the toe or the starting point of the jam. This is going to be where your ice jam starts, often because of, say, a bend in the river, a bridge, or a solid ice sheet that's preventing the ice from flowing freely. And this is an actual shot of the same scenario that we saw in the other schematics. Okay, on the left of your screen, you have the head of the jam, and you can even see from this photograph that their water is elevated from backwater. You've got a lot of rubble ice or block ice in between, and then you have where the jam begins at the toe of the jam there on the right, likely encountering a solid ice sheet. Okay, so now to talk about the types of jams that we have. Freeze up jams. This is often the first type of jammings that we get. It often occurs when we get some kind of an Arctic blast or really cold snap, and you get a rapid development of river ice. The freeze up jam often occurs early to midwinter. The flow will steadily build upstream until the jam ultimately releases, unless it's able to either go underneath the jam or sometimes it will actually find and create a new channel around the jam. So the strength of your freeze up jam is going to depend on how cold the temperatures get. And as mentioned before, the frazzle ice that comes in from upstream can actually act as glue, solidifying that jam more and more in place. So a freeze up jam can grow to tremendous proportions. They definitely need to be monitored and their progress reported. Now, freeze up jams are concerning for flooding, mainly from the backwater effects. However, when it comes to flooding concerns, it's more the breakup jams that can cause problems. Now, of the breakup jams, there are two types. The first is probably the most preferred method of breakup. This is the thermal breakup. It's a gradual melt out of the ice. The ice will melt in place, often undramatically with limited or no flooding. It melts from the heat transfer from the water underneath and more notably the solar radiation and the exposure on the top surface of the ice. And then we have mechanical breakup jams. These are the most concerning. Mechanical breakups are often triggered by an increase in the flow, which stresses the ice cover, causing cracks, fragmentation, and ultimately the movement of these large ice chunks. They're the most dangerous because you can often have very large ice fragments, right? Unlike with a thawing jam, these are very cold and strong ice chunks. So they're often also accompanied by a lot more stream flow. And it doesn't take a tremendous amount of increased flow to break up that ice, especially for your smaller rivers and creeks where it doesn't take as much water to raise the water levels. A general rule of thumb that we use is that it takes about 3 times the river ice thickness for an ice jam to occur. So in this example, if the ice is about a foot deep, we only need a river rise of about 3 feet for the buoyancy to break up the ice. Now, it's very often that when we have ice jam season, the same areas are often affected. So for spotting purposes, the most likely areas to find a jam are in common problem areas. Bridges, bends in the river, that's very common. The upstream end of a solid ice sheet, that can vary from season to season, but they can all be barriers and the starting point for your jams. Okay, so here is a video out of a relatively small brook in Vermont that had an ice jam that broke. Okay, so you can see in that video that there's a sudden surge in water in large chunks of ice. So essentially what this is demonstrating is that an ice jam break can be quite flashy, similar to a dam failure. That's why we need to know where jams are located and identify any downstream risk, ideally before the jam breaks. Now, this is a very small brook. Imagine that same scenario, but on a much larger river. So if you're not familiar with the Weather Service's standard operating plan for river flooding, is that we utilize the USGS along with some other networks of stream gauges. However, whenever there's ice present, or even just during periods of extreme cold, the reliability of this gauge network can be called into question. It can provide fictitiously high readings and give us questionable data. However, there are some useful advantages to having these gauge networks and identifying ice jams, but overall, our ability to model and forecast flooding as a result of the gauge network is just not the same as it is when we have natural flowing rivers. Okay, so now I'm going to shift our focus a little bit and talk about how we at the Weather Service operate when we have rivers that are impacted by ice and the respective products that we issue when faced with certain situations. I'm not sure how many of you are familiar with our river flood warning program, but we do have a separate web page. It's called the Advanced Hydrologic Prediction Services, where you can see these little dots representing the river gauge networks across the region. And at those points, you can get river forecast information. However, as stated before, our ability to monitor river ice is very, very challenged. So the Weather Service will cease issuing the forecast for the stage and the impacts, but we will continue in some instances to forecast the flow information, which can be modeled accurately. So what we encourage people to do is that we have river ice situations is that you get your flood information not from the AHAPS page, but go back instead to your weather.gov weather forecast office page instead. Okay, so say we're faced with a scenario where we have been notified that there is ice in the rivers, again, 4 inches thick or more, to the point where it can present a hazard for jamming. And we have, say, a thaw event coming up or some other system that's going to cause the river levels to rise. At this point, we're not exactly sure in the details, like which rivers are going to flood and where, but the region is under a threat. So we'll likely go with something called a flood watch that can be out for 24 to 48 hours. Now, the most notable of our warning products is the flash flood warning. So for these products, oftentimes either a spotter reported a rapid rise in water or perhaps one of those USGS river gauges indicated that, and it's reaching hazardous levels. At this point, the rapid nature of the flooding is what's going to cause us to issue that flash flood warning. Don't forget that unlike with a standard flash flood, when you have ice chunks in there, especially large ones, the ice itself can become a hazard and has been known to strip down trees, take out decks, damage homes, uh, regardless of the actual water impacts. So flash flood warnings, again, are the most impactful and the most significant type of warning product that we have, and it's likely triggered by a rapid rise in water. But not all floods come in a rapid wall of water, right? So if it's a more gradual rise, but still just as impactful, we may issue a flood warning. So for these, we'll issue a flood warning. The information that is provided by you, our spotters, or other people on the ground is often what we put actually in our text product. where we're describing what the hazard is and where the impacts are located. But to be a flood warning, there really does need to be a threat to life and property. As mentioned earlier, the Weather Service will cease issuing standard river flood warnings when we have ice present. Now, what happens when we get flooding on one of those rivers? Well, at that point, we will instead issue a standard flood warning where we will talk specifics about that river, but we won't have information on like the future water levels and the crest. The information will be more vague in terms, and a lot of the content will be dependent again on what we're hearing from you spotters. Okay, so say we had a flash flood warning out for a scenario where the water came up really fast and flooded a fairly large community. Now, the water's not rising anymore, but neither is it receding, or it's receding very slowly. We're not going to issue another flash flood warning because the rapid rise in water has ceased, but there's still hazardous conditions out there. So we sometimes will follow up or replace that flash flood warning with a flood warning that could go on for a fair amount of time. Sometimes with an ice jam, the floodwaters can remain elevated for some time. And you may also hear on occasion us issuing a flood advisory. Now, the way to think of a flood advisory is nuisance flooding. It might flood, say, a secondary road or a park. So there are impacts, there's flooding, but it's not a threat to life and property. All you need to do is simply avoid the areas where the floodwaters have come up. Now, this product is issued by the Weather Service offices in Caribou and Maine, but currently not by the Weather Service office in Burlington. In fact, this is a product that will probably be discontinued in the next few years. So now we circle back to the role of the spotter. For those of us at the Weather Service or the state emergency management offices, it can be challenging for us to receive real-time information that we can then turn around and use to either protect or alert communities. So in order to have that valuable real-time information, we're counting on our spotters to letting us know. This is directly tied to the safety of your community and those downstream and upstream as well. So most importantly, and I really cannot emphasize this enough, is to please stay off the ice. There are state and federal officials authorized to go on ice, but for most of us, it is an unnecessary risk. In the image here, you can see some ridging of ice sheets that has left a cavernous hole that could very easily have collapsed under this observer. Very dangerous situation. Likewise, with the actions of these gentlemen here. Just one little shift in the ice and it could have been a very serious situation. Unlike a lake, the river is constantly moving body of water. This can easily cause shifts in the ice. Also, never drive into flooded roads. I need to emphasize that we do not want people to ever enter any flooded roads. Our first responders with the cold water rescue teams would appreciate it if we not take such a dangerous risk. Okay, so some observational best practices. So when going out to spot for an ice jam, try to find a site that's elevated so you can get a good vantage point up and downstream. You can see in the example here, we have an observer on a local bridge, notably wearing a yellow safety vest for visibility. So that location is very important. Helpful if you're near a USGS stream gauge, but not necessary. Absolutely not necessary. I think if you can find a stable and safe part of the river's edge, it could help avoid being on a roadway where you have the secondary hazard of motorists who might not be paying attention. So again, safety is the most important thing that we need to keep in mind. So here are some pictures of some observers on taking their observations from a safe location. You can see they're on the riverbank, stable portions of the riverbank, or on a bridge, but wearing that, again, that safety vest for visibility to motorists. Okay, so we recognize that not all river locations are easily accessible, right? Those bends in the rivers up in the forest. So this is where drones have really paid off with their ability to take aerial photos and videos of jams and do it safely. So if there's an opportunity to use a drone please send that information to the Weather Service. I need to emphasize this though, prior to their use, make sure that you are familiar with any local policies on their usage. Um, we don't want anybody getting into trouble by using their drones, but if available, that information is quite important for us. Okay, so now that you've taken your observation, it's time to call it into the Weather Service. So the information that we're going to need, make sure that when reporting the river or stream name that you associate it with a town or a county. For example, we have several mill creeks and we want to make sure that we're making an alert for the right county. So please try to give some detailed information on exactly where on the creek, if there's a mile marker or a bridge for reference. Approximations estimates are fine because the ice will shift over time anyways. For example, the ice starts about 100 yards upstream of this bridge. That's great. Try to give us a description of the ice coverage and type if possible. For thickness, again, we do not want you to take any unnecessary risk. If there is shore ice that can be measured safely, then that's fine. Otherwise, an estimate will suffice. Okay, so here's an example of an ideal report that I received a few years ago. The spotter used an online map to denote the start and end of the ice jam, or as we've learned here today, the head and the toe of the jam, along with any sites of flooding. Pictures were included with the email with permissions for us to use them. So this is an idealized kind of gold standard on the type of report we would love to receive from you spotters. But again, if time is of the essence, a phone call will certainly suffice. And speaking of phone calls, if you find any flooding that needs to be reported immediately to us and also to your local 911s so that we can issue the appropriate warnings and your local officials can get those road barricade signs deployed. If you're concerned about a jam break, obviously any flooding or even any damages, say a dock got taken out by ice overnight, please report that to us. We prefer it if you do it as soon as possible. If it's something you heard through the rumor mill, you can still call that in, even if the flooding situation has lessened. That's the kind of information that's really important to us and actually would result in more of a call as opposed to emailing us or sharing it on social media. This is probably the most important slide in the entire presentation. You've taken your observation and now you actually need to submit your report. How do you go about doing it? Well, first off, it depends. Which area are you located? Which weather forecast office should you reach out to? Caribou, Gray, or Burlington? Honestly, if you're not sure, say you're out on the road and you're not in your general area, you can send it to your local office and that information can be forwarded on if need be. So as we stated earlier, if it's flooding or some urgent situation, you should call directly to the Weather Service office, and the numbers are listed here. If there's, say, no urgency, but you do want to share some, say, interesting pictures of the jam or just a report of the jam, you can share that through emails. The Weather Service in Burlington has a separate storm report interface that you can use. You can use social media, Facebook and Twitter, and share your information that way. I do ask that if you are sharing pictures, that you please provide credit and usage information, also the date and time stamp on when the picture was taken so that we make sure to keep up to date as ice jams are a constantly evolving hazard. Okay, so we're coming up on the conclusion, but some of the main takeaways is, ice jams don't happen all the time and they don't happen in the same locations. But if you look at the historical records for your region, you'll probably find some of the worst floods in your community have been influenced, if not directly tied to ice jams. They're very unpredictable, but I think the more information sharing and the more people we have out there spotting for us, the better our ability to assess the risk and try to put out as much preparedness information or warnings, if necessary, as we can. The biggest takeaway I hope you have is that for river ice events, we really cannot do it without you. Spotters are critical in our ability to have the situational awareness of the rivers and have any chance of providing timely warnings for the communities, including yours. But as much as we need these reports, we only want them if they can be taken safely. I want to give a special thanks to all of you. I can't emphasize enough how huge a role the Skywarn spotters have had in our success, and I hope to continue to engage with you in the future. Thank you. I want to again thank you for listening to this training, and if you had any questions, please feel free to reach out to myself, sarah.jameson@noaa.gov, or either of my counterparts with their emails listed here. Have a good day.